Hey, so I was reading this article from Nick. It's called Thundering Heads and Promises. He was giving an example about having like a backend and a caching layer and a bunch of like services, clients, workers, whatever, and they are all sending the same request. And instead of just caching the value in the backend, they will cache the promise, and all of these services that are sending the same request, the cache layer will just point that request to that promise, that cached promise. So instead of, for example, sending 100 requests that are identical, all of them will be like mapped down to one request, because one of them already sent the initial request, even if they were concurrent. One of them was the first one, so we cache that promise, and every request similar to it, we will just point it to that promise. So it's a really nice article, and he called it Thundering Heads. I think, I mean, I was reading I don't like to be this guy, but I was reading the exact terminology, or the definition in Wikipedia. It's a problem that happens when a large number of processes, like accessing a resource that was not available and maybe suddenly became available, for example, a server, and all of them will try to go there. And I mean, according to the definition, it says only one of them will access that thing, but I mean, I guess it's similar, but maybe not technically the same. But I don't think that matters. But I just wanted to point that out. But the idea is you have so many things that are similar, trying to do the same thing, accessing the same resource, and um, it could potentially harm your backend. It depends on what you are doing. Also, another use case, it could be, imagine you are building a package that, or a library that your clients will use, and like for example in AWS they have these SDKs you can call, hey, dot get or dot invoke lambda, uh, and imagine so many people call the same function, or you in your code base you invoke that function in so many places. You could somehow all of these invocations make them like one function call, or make them only fire one HTTP request, and all of the other calls will subscribe to that promise, for example. So let's say, for example, you have a function called get EC2 um, information, and you invoke it in 5 places. All of these will result in one HTTP request that will get the information, and all of them will get it. It's like batching up a bunch of requests into one. Um, that's one way to explain it, I guess. And I thought it would be interesting to actually implement it. So I will show you, I have a simple example here. So I have a server, super simple, happy server. Oops. I just have this path, you send a request, I have a global counter, I just keep increasing it. And I have here like my caching layer. And this is an array of requests that I simulated. So I have these requests coming from some clients, and you can see that they are similar. So they are all sending the same query params. And in this context, I would assume that all of these requests will result into the same result. So that's one reason why I can't do what I'm going to do in a moment, which is batching them up into like a single request, or mapping them all to the same promise that will result to the same value. Same thing in the article. So yeah, I'll show you now the example. I hope you can see it right. I'll put this here. So npm run server. This will run the happy server we have, and I will split the screen. Okay, npm run. I'll call it. It's called cache. I mean, you'll find the code in the description. So if I run it, you will see these 6 requests coming from whatever point or whatever client, whatever service. They resulted into 6 requests hitting our origin. So we could do better, and you can think of this cache.typescript file as like a gateway API. It handles all of the requests, and we have there a caching layer. So the way we will do it, I will create a cache map data structure, and the key is a string, and the value which will be a promise, and it will resolve to unknown. But because we are retaining a string, what I can do is change this type to Axios response, be a string, and it will be as simple as, hey, we need a first thing to cache every promise, we need a key. This key will be in our example, it could be as simple as stringifying the query object. So I will define a variable called query string, and yeah, I can do this. And I would say, hey, if cache dot get the query string, then what I can do, I can just simply await the thing from here, and I will extract the data. I think it's complaining because it could be undefined. One way to trick TypeScript, I'll define a variable called cached promise. Like this, TypeScript will know that we are pointing to the same variable that we checked it exists. But yeah, so now if I console log this, I will have this data object or this string, and else if we don't have it cached, can do something similar. Sorry, what we can do is create a promise. Promise be equal to this, and then I will go to the cache layer and I will set, hey, the query string, and the value will be that awaited promise or that promise value. Then I have to await it and then extract the value and just log it. Yes, this will do it. And also maybe I will define a result. And I will push. Just to show you that at the end, we have result.length will be equal to the requests.length. So yeah, all of these 6 requests should end up resulting into only 2 requests. And the way we validate this, I didn't show you this, but in our server, maybe I showed you this, I can't remember. We have this global variable, and every time you get a request, I increase it, then log it. So we can see in the beginning we got 6. Also in the response, I always return the new value. Let's add this emoji also here. Okay. I'll run it, npm run server. Now, if I run the cache again, I should only see 2. So like 2 requests reached origin, we can see from this result, but we ended up with 6 data objects, the data values, I would say. So yeah, we achieved what the article was trying to explain, which is, hey, all of these requests, we know that they will result into the same value. So instead of caching the value on the server and retaining it, that's also a completely valid option. You can do that. You can have an intermediate layer that will cache the promises, and just every request that will potentially result into the same promise, you just go and point it to the promise that you already cached, and that's it. So it's really nice technique, I would say. I liked it, and it could be used in so many places. Like you can use it in React. Imagine you have a lot of components, all of them are invoking the same function that will result into an HTTP request. So instead of all of them just keep bombarding the server with requests, you have this kind of layer written in somewhere in your React application that says, hey, if you are sending the same request that I already sent, I'll just go and point you to the promise. So instead of sending a request, you will get the promise back. But of course, one note, I think you already noticed this. This key for this key for the promise. I'm not sure if this function, I'm using this package called query string. You give it an object, converts it to a query param in the URL. So this Q2 will be converted to like this. Okay. But I'm not quite sure if this holds the same, like, because in objects in JavaScript, if you convert this to a string, or if you convert this into array and take in the keys, the order is not guaranteed, because in my eyes as a human, I see Q before B, but I think like in JavaScript itself, there is no order for the keys. So this query string potentially might not be the same string, even if you are sending the same object. Especially if you have multiple values. If one value, it will always be the same, but multiple values, it might be different. I would say. So one way to make this perfect, which I don't think is important in this video, I'll just mention it, that you create a function that extract these values and keys, sort them, that will be the key. So you should always sort them after you extract them. But I just wanted to show you the main idea. I mean, after implementing it, it feels a bit silly because it feels simple, but I would say it might be nice, because I tried to research about it on the internet. I only found some like articles like this, which is nice. Like I like them, but also I wanted to see some kind of implementation, and I thought it will be harder than this, but yeah. But of course, this does not handle things like failures and other stuff like that. For that, I have a YouTube playlist handling HTTP errors. I'll put it in the description. Put my name. No, handling HTTP retry. Maybe this will be something useful to you. Yeah, I will put it in the description. That's a way to handle retrying requests when they fail. Yeah, I think the last thing we can do is let's actually create a big array of requests and run it. This would be 1,000. Or run the server. Run the cache again. So if you see, we from 1,000 promises, we only got back, we only ended up with 2 of them reaching the origin, which is the server, and the rest of them just used the cache. I would say that's pretty good. Yeah, that's it. Bye.